In the next exam question, we have a 3 kilogram trolley that is at rest on a horizontal, frictionless surface. A constant horizontal force of 10 newtons is applied to the trolley over a distance of 2.5 meters. When the force is removed at point P, the trolley moves a distance of 10 meters up the incline until it reaches its maximum height at point Q. While the trolley moves up the incline, there is a constant frictional force of 2 Newton acting on it. So remember, in order to solve your physics problems, it is always helpful to first take this information and go and put everything on one diagram. Here we were told the trolley starts from an initial position of rest, therefore the initial velocity is equal to 0. An applied force of 10 Newton was applied on the trolley over the first horizontal frictionless part. At point P, we no longer have an applied force, and my trolley moves a further 10 meters up an incline until it reaches its highest point at point Q. So remember that whenever something reaches its highest point or turning point, it means that the velocity at that point will be equal to 0. If we look at the free body diagram for the horizontal part, we have an applied force, the normal force, as well as gravity. On the incline plane, we no longer have an applied force, but we still have the normal force. And remember that this force is 90 degrees to the incline. We still have gravity as well as friction. So remember that gravity we can split up into Fg parallel as well as Fg perpendicular. Now having a look at the free body diagram on the incline, we can see that friction is working down. The reason for this is because my displacement is still up the plane, and friction is always opposite direction of motion. Now that we've summarized the information given, we can have a look at the questions. 5.1 says, write down the name of the non-conservative force acting on the trolley when it moves up the incline for 1 mark. So remember that in the previous video we had an in-depth look at what non-conservative forces are, and the two that we use mostly is friction as well as applied force. Now having a look at the free body diagram up the incline, we can see that we have a frictional force present. Therefore, the frictional force is the non-conservative force, seeing that it is path dependent. In 5.2 it says, draw a labeled free body diagram showing all the forces acting on the trolley as it moves along the horizontal surface for a total of 3 marks. Now remember that the mark allocation for any free body diagram is exactly the amount of vectors that you need to draw. So remember that on the horizontal surface we have no frictional force, we only have an applied, a normal, as well as gravity. We can always go and check ourselves to make sure that we have the amount of vectors as the mark allocation. In 5.3 it says, state the work energy theorem in words for a total of 2 marks. So remember that the work energy theorem tells us that the net work done on an object is equal to the change in kinetic energy of that object. We can now use this formula from your data sheet in order to state the work energy theorem. In 5.4 they then say, use the work energy theorem to calculate the speed of the trolley when it reaches point P for a total of 4 marks. You can now see why it is important to know and be able to identify your theorems, because they usually ask you to define it in the one question and then they ask you to use that theorem in the next question. In this question we were asked to calculate the velocity at point P. The initial velocity for the trolley was 0, seeing it was started from a position of rest. Looking at our free body diagram, we can see that we only have an applied force working in the direction of motion. And my displacement is also to the right. So remember that displacement is also a vector, and in this case I'm indicating my displacement, seeing as when we calculate work, work is the force times displacement and the angle between these two vectors. We can now use the work energy theorem in order to solve the speed at point P. On the trolley, we have 3 forces working in on it. We've got gravity, applied, as well as normal. But not all of these forces will do work. Seeing as gravity versus my displacement works at an angle of 90 degrees, the gravity does no work and will therefore be 0. The same applies for my normal force. My normal force to displacement work in on each other at an angle of 90 degrees, and the cos of 90 is equal to 0. The angle between the applied force as well as my displacement is 0, and therefore it is a cos of 0. Which gives us a speed of 4.08 meters per second at point P. In 5.5, they ask us to calculate the height h that the trolley reaches at point Q for a total of 5 marks. So remember, at point Q it reaches its highest point where the velocity will be equal to 0. At point P we just calculated the velocity, which is equal to 4.08. Now we can see that we have a change in velocity, delta v, as well as a change in height. We're going from an initial height of 0 to a final height of h. Looking at our free body diagram, we can see that we have the following vectors working in on the body as it's moving up the inclined plane. And seeing as we have friction, which is a non-conservative force working in on my body, we can make use of the non-conservative formula, which states that the work done by a non-conservative force is equal to the change in kinetic energy plus the change in potential energy. The frictional force was given as 2 Newton and the inclined plane is a total of 10 meters in distance. The angle between the frictional force and my displacement is 180 degrees. Here my final height is a height of h and my initial height is 0, seeing as it is on the ground level. My final velocity is at point Q, which is 0, and the initial velocity is here at point P, which we calculated as 4.08. Which then gives us a height h of 0.17 meters.